So our next problem is that the following four conditions are equivalent. Before solving this mathematically, let's try to understand this with diagram. This is Venn diagram. This is universal set. We are taking a set A and this is a set B. Okay. So the first condition is satisfied. A is the subset of B. Okay. Now A minus B equal to 5. Is this satisfied? If we eliminate elements of B from A, what we will get? Nothing. The A itself got subtracted from itself, so the set will be 5. And the next one is A union B. If we union A with B, A and B, the whole set will come out as a result. So this will be B. Okay. And if we take intersection between A and B, then what will happen? This will be the set A intersection B. The common elements between A and B will be this. This is A intersection B. And what is this? This is the set A itself. Okay. So now we will be solving this problem mathematically. So we will be starting from this 2, 3, 4 condition and end in condition number 1. Why? Because I think it's a easy procedure. Why? Because we know the simple definition of subset. What is the definition? If X belongs to A implies X belongs to B, then A is subset of B. This is the definition. If any element belongs to A implies that element also belongs to B, then A is the subset of B. Okay. So we will start from number 2. Okay. So here what we say, let X belongs to A. Okay. So we can say clearly X belongs to B. Why? Otherwise if X does not belongs to B, then A minus B not equal to 5. Let us simply take an example. Okay. Suppose A is a set 1, 2, 3. Okay. We are subtracting from B, that is 2, 3, 4. The result will be singleton set 1. Why? There is exist an element 1 in the set A which does not belongs to B. If 1 does not belongs to B, then the subtraction result will not be 5, the null set. So if X belongs to A, that we must imply X belongs to B. 1 must be in B to get the result 5. Okay, every element of A will be in B, must be in B to get result 5. So as X belongs to A implies X belongs to B, we can say that A is subset of B. Okay, number 3 is very easy. Let X belongs to A. As X is belonging to A, so Ax must belong to A union B, because A union B means X is either in A or in B. So or in both, maybe in both. Okay. X so here X is in the set A, so X must be in A union B. What is the value of A union B? Is B. So X belongs to B. We can say that X belongs to B since A union B equal to B given in the statement. As X belongs to A implies X belongs to B, then A is subset of B. We can write A is subset of B. Number 4, it's also easy. Let X belongs to A. Now implies X belongs to what? A means A intersection B given in the statement. Since A equal to A intersection B given. What is the definition of intersection? It means X belongs to A and X belongs to B. There X is the common element of A and B. So X belongs to A and X belongs to B. Here or here is and. So we get X belongs to A implies X belongs to B. So by definition A is subset of B. This is how we will prove this problem. So our next problem is question number 5. So that if A is subset of B, then C minus B subset of C minus A. So from the previous problem, we know the definition of subset. Okay. So what we have to show to prove this? Okay. What is the plan to execute this problem? If X belongs to C minus B implies X belongs to C minus A, then C minus B is a subset of C minus A. We have to show this. X belongs to C minus B implies X belongs to C minus A. Then this will be automatically stated. Why? This is the definition of subset, just like the previous problem. Okay, so this is our plan. This is our plan and this is our goal. Okay, so we start with let x belongs to c minus b. We started with this. Okay, so let us understand first. This is a universal set, this is c set, this is b set. Okay, what is the c minus b? C minus b means the red portion. Okay, the red portion is the c minus b part. So now what does that mean? By definition, x belongs to c. X is inside the element set c, x element, and x does not belongs to b. X isn't in the set b, you can see from the diagram. Okay, now what we are implying? X belongs to c and x does not belongs to a. Okay, where is a? A is just like here. This is the set a. Okay, so you imagine if since we can write that a is subset of b, so if x does not belongs to b, then x does not belongs to a. Any element which is not present in b, that will not present in a. Why? A is subset of b. Suppose we take an example, 1 2 is set a and 1 2 3 4 is set b. So 5 is not in set b, then 5 will also not present in set a. Suppose this is a, this is b. Okay, this is from the diagram you can also understand this. Okay, so what does that statement means? X belongs to c, x does not belongs to a. It means x belongs to c minus a. X belongs to c minus b means x belongs to c and x does not belongs to b, and x belongs to c, x does not belongs to a means x belongs to c minus a. So we achieved our statement that x belongs to c minus b implies x belongs to c minus a. We started from this, we ended here. So by definition c minus b is subset of c minus a. Just we have to plan how to solve it and then we have to execute the problem. This is how we can solve this problem. Now what is our next question? Assume that PA is equal to PB, power set of A equal to power set of B, so that A equal to B. So how we will solve that? Our plan is how to achieve this. We have to show that A is subset of B and B is subset of A. Then it will be automatic A equal to B. Okay, we have to show this and this. To show this, what we have to show? We have to show x belongs to A implies x belongs to B. Then it will be achieved. And for this we have to show y belongs to B implies y belongs to A. Then this can be achieved. So this is our plan how to solve this problem. Okay, so first we solving this portion. Okay, now we are separating this. We will be solving first this and this. Okay, now so to solve A subset of B, let x belongs to A. X is any arbitrary element of A. Okay, so then there exists a subset, say S of A, such that x belongs to S. So there x is an arbitrary element in A, and there is a subset S of A which contains the element x. Now it is obvious that S is subset of A. We assume that S is subset of A. Okay, so S will belong to the power set of A. Why? Power set of A contains all the subsets of A. So definitely S will be in member of power set A, power set of A. Now we are saying that S is also a member of power set of B. How? Since given power set of A is equal to power set of B. Okay, it's given. So S is also element of power set of B. Now what are the elements of power set of B? The subsets of set B, all the subsets of set B are in the power set of B. So S must be a subset of B. All the subsets are in the power set. So if S belongs to power set of B, then S must be a subset of B. So now X is a element of S, set S. X is a element of set S, and S is now subset of B. This is S and this is B. You see that? This is S, this is B. Okay, this is the universal set. So if x belongs to S, then x must be inside B. If x is an element of S, then x must be an element of B. So we started with what? X belongs to A, and we implied what? X belongs to B. Then what we can say? A is subset of B. So we achieved this. Now we have to achieve this one, B subset of A. So for that let Y belongs to B. So then there exists a subset, say T, of set B such that Y belongs to T. Okay, so Y belongs to B, and there is a subset of B which contains the element Y, which is T. Now T is subset of B, we assume that. Now as T is subset of B, T must be belonging to the power set of B, because power set of B contains all the subset of B, so T must be an element of this. But now T belongs to power set of A. Why? As given P of A is equal to P of B, power set of A equal to power set of B. Okay, it's given. Now what are the elements of power set of A? All the subsets of A are the elements of power set of A. So T is also must be a subset of A to be an element of power set of A. So T will be subset of A. Now same here, this is A, this is T. So Y belongs to T, Y is an element in T. So the element Y must be an element of A, because T is subset of A. Okay, so Y must be belonging to A. So we started what? We started with Y belongs to B implies Y belongs to A. Then we can say that B is subset of A. We achieved this. Now as A belongs to A is subset of B and B is subset of A, we can write what? We can write A is equal to B. This is by definition. If A is the subset of B and B is the subset of A, we can write A equal to B. We planned the problem and we solved by the planning. Okay, this is how we can solve this type of problem. So is it true for any sets A and B, power set of A union power set of B equal to power set of A union B? Is it true? This statement for any set is not true. Okay, this is not true. So we have to justify our answer. Okay, this statement is not true. So for justification, let A is equal to singleton set 1, B is equal to singleton set 2. So you may ask why I have chosen only singleton set. Why not a set containing multiple elements? Because we know the number of elements in power set is 2 to the power m. If we if we consider set containing 2 elements, the number of elements will be in power set is 4. For 3, we will get 8 elements in the power set. And as we consider only one element in the power set, only in the main set, so the power set number of elements in the power set will be 2. To reduce the size of the problem and labor invested to solve the problem, I consider only singleton sets. That's the reason. Okay, so from here we can say that A union B will be 1, 2. Okay, now power set of A will contain the null set and the singleton set 1, and power set of B will be the null set and the singleton set 2. Okay, and what about the power set of A union B? Power set of A union B will be the null set, the singleton set 1, the singleton set 2, the set 1, 2, the A union B set itself. Okay, as it has 2 elements, the power set will have 4 elements. 2 to the power 2 equal to 4. Now P of A union P of B, that is the left hand side. Okay, what is the value of it? The sets containing P of A union P of B will be 5, singleton set 1, singleton set 2. That's all, and which is not equal to P of A union B. The element 1, 2 is extra in P of A union B. P of A union P of B contains only 3 elements, whereas P of A union B contains 4 elements, so they are not equal. This is the this is an example to show that's not true. If for any example it's not true, then the statement is wholly not true, because in the statement it's written for any sets A and B, and A and B are two arbitrary sets we have chosen. So if for one example it is not true, then for as a whole the statement is not true.